Yes. Okay, so wanted to take you on a little bit of a tour and explain to you a little bit about what we do here in the X-ray program. A lot of people have had chest X-rays when they were sick with a cough or something, or they might have fallen off their skateboard or bicycle and injured their arm, injured their hand, maybe had an X-ray done. So that's what we do. You know, that's our living. And so what we have all this equipment, and I wanted to give you just a brief overview of how this stuff works. Taking X-rays uses a lot of electricity. So here's our panels. We have electricity coming into the building, and the electricity is processed in this big box over here, which is, it houses our transformer circuits. Now, regular electricity is 220 volts, but that's not enough to make X-rays with. We need at least 50,000 volts in order to produce even just like a finger X-ray. So there's a lot of energy here. And in medical radiography, you're going to be using typically from 50,000 volts up to about 140,000 volts. But all that electricity comes out of that box there. And the electricity travels through these very, very well insulated cables and comes down and winds up at this X-ray tube. This is where the 140,000 volts of electricity is going to wind up. And inside this X-ray tube, that electricity is converted into X-ray energy, which is a form of radiation that can penetrate most tissues. It can penetrate all organic tissues, and it can penetrate a lot of metals, you know, things like that. This is a digital X-ray imaging plate. This particular plate just happens to be a Fuji brand, which is that's a very high quality plate. We also have AGFA and Rayance systems here in our laboratory, in addition to having regular film. So if I'm going to take an X-ray, then I might have this plate, and I could take a skeleton hand, put it on there, bring my light field over and position it properly. And this is part of what we teach you in the X-ray program, is because there are specific places where you're supposed to aim for each part of the human body. So I can do this on the tabletop, or if I had a bigger patient, or if I was trying to X-ray somebody's pelvis or abdomen, then I would put this plate into the bucky. We're very fortunate here at CFCC to have a full body mannequin which has a real human skeleton inside. So this is what we do a lot of times. We will X-ray this phantom because we're not allowed to X-ray regular human beings here in the laboratory. Here are the body parts we are allowed to image. We have a lower torso, that's a lumbar spine and pelvis. We have an upper torso, which is the chest and thoracic spine. And then we have a skull, we have a foot, we have a knee, an elbow, and as we saw a few minutes ago, we also have this hand. I have a few more phantoms that are in these black boxes down here, but don't want to break all those out. You get the general idea. Now, what if your patient can't hold still? Well, or if they have a problem rolling up at a 45-degree angle. No problem. We have a lot of sponges and sandbags here that we can put around the patient to help hold them in position. This is the control panel. As you can see, it's just got a series of buttons and a display here. So say, for example, I want to take some images of a patient's cervical spine. Well, I can select cervical spine, and then I can select which view of the cervical spine. So we usually start off with a lateral, so I would go ahead and select that. The computer automatically programs 80 kilovolts and 80,000 volts and 15 milliamp seconds. That's what the MAS stands for. That's just a combination of how many X-rays we're going to use per unit of time. And again, those are the kind of things that you'll learn when you come into the X-ray program. It's, you know, everything we do has a scientific basis behind it. Now, you're probably wondering, well, wait a minute. If you expose your patient right now, aren't you going to get a big dose of radiation? Why, no, I'm not. You see this great big window right here? This thing is a very expensive item. It is made out of leaded glass, and it is pretty much radiation resistant. Any scatter radiation that's coming my way, this window is going to stop. And we've tested this thing over and over again, and it works really well. Okay, so let's step through it start to finish. So here's what we're going to do. I'm going to select skull and facial bone. I'm going to select lateral skull. As you can see, I do indeed have the skull phantom in there on the image receptor. Okay, very good. So now all we need to do, like we were saying before, we're going to prep and shoot. Okay, so now we should have a picture of a skull after we process it. And if I did my job correctly and I got everything lined up like I was supposed to, then we should see an X-ray of the patient's skull. And you see that R marker on there? What that means is that the patient's right side was closest to the image receptor whenever we made this exposure. That's something that we do so that the radiologist knows how to orient this picture. So for example, what they might want to do, if the doctor sees this, he might say, oh, okay, well the right side was down, so therefore I should probably just flip this thing over so now it looks more. This is how the picture was taken. So that's the good thing about with computerized imaging. You can change the image if you want to. There's some, you can make it darker, you can make it lighter, you can enhance the soft tissues, you can enhance the bone. Whatever you want to do. And then once you get done playing with it, you can put it all back like it was and then exit out, you know, so then the next person can come along and look at it and then they can make any adjustments they feel like are necessary. So anyway, okay, so that's kind of what we do. And then once we get this image taken and I want to send it to the doctor, I just click on this study completed, and the computer knows to save this to the database and also transmit it to the doctor's workstation. In addition to our energized room that you've already seen, we also have this tube that is not energized, but we can use this table and tube for positioning practice, and we do that quite a bit. That is an upright chest stand, and to use the upright chest stand, what we do is ask our patient to walk over and just stand in front of it, and then we can take x-rays like chest, shoulders, cervical spine, skull, sinuses, basically anything that we can do with the patient standing up, we can use that chest stand and obtain weight-bearing images. But if the patient is really sick, then we won't have them stand up because they might not be able to stand up. So if they can't, then we'll just lay them down right here. So that's a very brief tour of the Cape Fear Community College Radiography Lab. I'll be kind of hanging out with you. If you have any questions, please let me know. And if you're interested in our program and finding out more about it, we have a web presence. It is www.cfcc.edu/radiography. So pretty easy to remember. Cape Fear Community College /radiography, and we have information on how to get in, and then we also have some videos that were produced by our students that kind of give you an idea about what it's like to work as a rad tech at the hospital. So that's interesting stuff too. All right, thanks very much for your attention. I appreciate it. Have a great day.